Hello everybody and welcome to the MLBrain channel. Today we're going to dive into why this is so increasingly important to scale your features before you're going to pass this as an input to your KNN model. We will start this episode with a short but very interesting practical example that's going to use Palmer Penguin's dataset. In case you want to use this data on your own, please feel free to go down below this video where I will provide all the source links in the description. The first thing we're going to do here is to download and install necessary Python packages to run the example code. We're not going to waste our time here, so if you want to take a detailed look, please follow the link I provided in the description to this video with the source Python notebook code. And let us prepare the Penguins dataset. If I run the code cell you see right now on the screen, we will see that the source data that represents the input to train your KNN model consists of several features, which is build length in millimeters, build depth in millimeters, flipper length in millimeters, and the body mass of the penguins measured in grams. However, if you want to have a more detailed understanding of what all these features mean, please follow the links. I again will provide everything in the description, which will provide you with a more complete understanding of what the build length, build depth, and other features stand for. Okay, after we've collected the data, this is time now to visualize that. And if I run the code cell below, we can see that if we plot this in the dimensions of the flipper length in millimeters and build depth in millimeters, we can indeed see some sort of two clusters here that correspond to two different genders of penguins, male and female respectively. You can see them plotted in orange and blue colors. And we start seeing that we can actually plot some kind of a line over here that will distinguish between the genders of the penguins. However, you can definitely spot that two classes overlap with each other, so probably the model that we're going to be working with will not be 100% correct. So let us try to implement the KNN classifier and see how it performs. But stop here and be careful, because before we feed this as an input to the KNN classifier, this is now time to split this into the training and validation subsets. This is done for the following reason. We're going to use the training set to actually train the KNN classifier, while the validation set is a subset of the original data that's going to be used to evaluate how well the KNN classifier actually performs on the data that it sees for the first time. In other words, how well it performs on the data that was not introduced during the training process. So we've prepared the source data, visualized it, and split into the training and validation subsets. Now let's actually create the KNN classifier and fit it on a training subset. You're going to see it in the code cell here. We've created and trained the KNN unscaled, which means that we did not use the pre-processing. In other words, we didn't scale the data before the training. Now we're going to report how well the KNN classifier performs on the training and validation subsets. If I rerun the code cell here, we see that it has the 84% accuracy on the training data and 81% accuracy on the validation data. Okay, now let's take a look at what happens if we scale the features of the original data before we use this as an input to train the KNN classifier. For this reason, in this line of code that you see here on the screen, we are creating the min-max scaler. We're going to talk about this in the other episodes. But what we're going to do here is to fit transform this on the training subset and apply it to both training and validation subsets of the data. This way we ensure that the scaler has been applied to both training and validation datasets. In the next cell of code, we're creating the KNN classifier once again, but notice that it's called KNN scaled. So we're going to call the .feed method and report the accuracy of the KNN scaled on the training and validation subsets. So we're essentially going to do the same thing, with the only difference that we're going to apply the feature scaling at the training and validating steps. So you see that in the next code cell, if I rerun the code cell, we increase the training accuracy to 95%, while the validation accuracy is increased to 90%. So just changing one pre-processing step and adding the feature scaling we're going to increase substantially the training and validation accuracies. But let's visualize this and compare the results in the next section. The final chapter of this notebook is to compare and visualize the final results to actually see how much we gain if we're going to add the feature scaling step while working with the KNN model. So if I rerun this code cell here, we end up with a plot which compares the training and validation performance before the feature scaling and after the feature scaling. So we end up with a substantial increase by 11% on the training dataset, while the increase in accuracy on the validation subset is astounding 9%. So we have actually gained an immensity of model performance, guys, just by adding one simple step, which is the min-max feature scaling. We substantially increased the accuracy of our KNN classifier. And that's it for today, guys. Thanks for watching this video. The purpose of this episode was to clearly show you why this is so important to scale your features before you're going to use this as an input for your KNN classifier. Please feel free to like this video and subscribe to this channel. It helps me indeed a lot, and I really hope to see you in the other episodes. So always welcome to the ML Brain channel. Goodbye.